Hello, my friends. Alex Zhavoronkov here, and I'm continuing my series of experiments with live broadcasts. Um, as you know, last time I tried it, it dropped due to unexpected technical difficulties, and that was turned out it was a problem with the network. Today, I'm going to try to do a better job. Let's see if it works. And I'm going to be talking about very briefly about the two papers that just went live by InSilico. One talking about the use of transformers for aging research, and another, our precious 2GPT paper just hit the NPG aging pages and is available open access. So you can check out this new model. And I think that both of those papers are very important because they talk about how to capture the basic knowledge of biology in time. So we all know that biology happens in time, from cradle to the grave. So from the time you come into this world to the time you leave it. Biology happens, and it happens at many, many different levels, from the quantum level, molecular level, cellular level, tissue level, organ level, systems level, organismal level, and even psychological level and societal level. And we've got massive epigenetic influence. So all that plays in time. And previously, it was not possible to capture the many patterns of previously disconnected data in time. And now it is possible because every living system has age. And that feature unites all of us. Every one of us has age. Not every one of us has cancer or some specific disease. InSilico, starting 2015, started training deep neural networks on previously disconnected diverse data sets coming from public sources to predict age. So we started calling that deep aging clocks, and our first one was published in 2016. I think that was the first application of deep neural networks to biological age prediction. Since then, we published many of those, what we call aging clocks. And starting 2022, we started building transformer neural networks that are multimodal and capable of performing multiple tasks. Using age, again, as one of the main features that we use for training and generation. And today, without further ado, let me share my screen and talk a little bit about our latest model called Precious 2GPT. And let me see if I can share the screen. If you go to insilico.com, it has multiple different buttons here that allow you to explore our offerings. And one of these links going to Precious GPT will get you to the Precious series, our multimodal, multi-omics, multi-species, multi-tissue transformers. I like to refer to them as life models. We have Precious 1 GPT, Precious 2 GPT, Precious 3 GPT model. They perform different tasks and allow you to get to different objectives. Our Precious 1 GPT was published in 2023. We developed this model in 2022. It's a combination of a transformer regressor and transformer classifier capable of prediction of age and target discovery. Precious 2 GPT that I'm going to talk about today, you can read the paper in NPG Aging. It's a transformer plus diffusion combination of two models that allow you to synthesize high quality multi-omics biological data and also identify targets. And Precious 3 GPT, it's our most capable model to date. Currently, the paper is on bioRxiv, and if you actually click on this, let me see if you can see what I'm doing here. Let me actually share the entire screen so you can see what I'm doing. And this precious 3GPT model is currently able, I will need to stop sharing and share another window. So precious 3GPT is capable of age prediction, target discovery, generation of certain synthetic biological hypotheses and data, and is trained on methylation, transcriptomics, proteomics data, also many different text repositories, including multiple publications, knowledge graph data coming from in silico. These data types are independently tokenized, and one global model is trained to perform multiple tasks, including, again, target discovery and drug repurposing, drug discovery. It can do natural compound modeling, omics interpretation, so it can do classification of omics data types. So it's a very capable model. You can join the community on Discord and use it, and it's also open source on Hugging Face. We're growing this community, and once the system gets significantly independently validated, we will submit to a hopefully high-profile journal. So now let me tell you a little bit about our precious 2GPT model. And here, this paper just went online in Nature and PG Aging. It's a peer-reviewed journal focusing on aging, currently running on generative AI for aging research. And here we published our very capable model, precious 2GPT. It's a combination of and diffusion architecture. And it's trained on longitudinal data coming from different species and coming from people of different ages. It is a pretty large cohort. It's only openly available data. And you can see that the input data is different tissues, species, omics data type, its expression and methylation, annotated with age. And we have two models trained here, conditional diffusion and multi-omics pre-trained transformer, that are capable of multiple tasks. They can generate synthetic data, help you discover targets. Also, it's integrated with our target discovery platform called Panda. It can create large open data sets without revealing the identity of the data donor, even though the data comes from public repositories. But we will also show that it's possible to synthesize data that keeps the donor anonymous. Again, just the capability of a model. And imagine that you want to create a few samples with the desired properties. You can just use as a dial in a kind of video of life. That's why we like to call it life models. And please read this paper. It outlines and lists many capabilities of the model. It also shows you several case studies. We use this model for target discovery in unison with our Panda Omics platform. Show how we can use the system for the discovery of targets in colorectal cancer. Again, the level of novelty of those targets is low. So you can kind of look at how it corresponds with the previous literature. And some targets are maybe moderately novel. And it shows other capabilities of the model. So please start using it, join the community, and also start collaborating with 3GPT. If you are interested in how to use transformers for aging research, please have a look at this paper. It also just went online 3 days ago in gerontology section. By the way, hardcore journal, very difficult usually to publish. And it describes, it's a review paper on how we can use transformer-based models, multi-modal, capable of performing multiple tasks, to capture new biological information in previously disconnected data types, and how to use those transformers for multiple tasks, and also how to try to recapitulate the central dogma from previous disconnected samples, which is a really cool capability of live models. Aside from that, I just wanted to highlight our conference where we are going to be presenting work at the end of this month. It's ARDD in pharma.org. I think currently is the largest conference for aging research on drug discovery in the world. It's a 5-day event organized by the University of Copenhagen and in Silicon Medicine. Over 150 speakers, over 750 people, scientists going to the conference. More than 50 startups participate, many of them sponsor. I'm very happy to be doing that with BCG again this year, so thank you, Michael Ringel. And at this conference, for the first time, we will present the capabilities of Precious 2 and Precious 3 GPT, and the new methodology for using methylation aging clocks for target discovery. For those of you who couldn't get the tickets for this conference because it's got sold out a few weeks ago, and now you cannot buy a ticket, you cannot even sponsor, because tier 1, tier 2, tier 3 sponsorships have been sold out for the first time in history of this conference in 11 years. You can get an online ticket and participate in the conference remotely, and then watch it online via video feed. Thank you so much. Let's ensure that we collaborate, work together on aging research, and use aging research for drug discovery, because again, biology happens in time, and we can, instead of referring to aging research as aging research, which we can refer to it as research of biology in time. So thank you very much.